Good morning, this is your Stat Sensei, Mr. Spensei, and this is classwork 3A.2 basic probability. We're going to break this assignment into two videos. This will be problems 1 through 13. So a die is rolled. Find the probability that an even number is obtained. Well, if I roll a dice, I can get a 1, a 2, a 3, a 4, a 5, or 6, which means there's 6 possible outcomes. And I need the even numbers. So that's 2, 4, and 6. So that's 1, 2, 3, 3 out of 6, which reduces to 1/2. Okay? Two coins are tossed. Find the probability that two heads are obtained. Well, if I'm doing something twice, which I am in this case, I'm going to make two blanks. Well, the probability of the first one is a head is 1/2, and the probability the second one is ahead is 1/2. And notice I use the word and because I have to have heads on the first one and I have to have heads on the second one. And means multiply. You multiply fractions straight across. 1/2 times 1/2 is 1/4. You could do this on the calculator, not a big deal. 1 divided by 2 times 1 divided by 2. It gives you a decimal, which I don't like. So math, enter, enter. So 1/4. Now, if you have 0.25, that's okay, but 1/4 it's much better to have it as a fraction because that's what we were working with. All right. Which of these numbers cannot be a probability? So it says justify your answer. Well, let's talk about probability. To be a probability, probabilities can only be between 0 and 1. So 0 less than or equal to x less than or equal to 1. They cannot be negative, they can only be positive. So this one's negative, so this cannot be a probability. So A. This one could be because it's between 0 and 1. So that's a possibility. This is greater than 1. It cannot be. 0 it can be, 1 can be, and this is a percent, and 20% are always divided by 100, and that's 0.2. Well, 0.2 is between 0 and 1, so it also can be. So the only two that cannot be are A and C. All right. Two dice are rolled. Find that the sum is, and then you got a whole list of questions. Okay, so let's look back at that. Anytime you have a dice problem and you're rolling more than one, um, it says two dice. As soon as it says two dice, we need to make a sample space. And I'm just going to tell you, you need to practice this. If you do it 3 times and you try to do it fast, you will get good at it. So here we go, 1, 1, 1, 2, because I can get a 1 on the first dice and 1 on the second. 1, 2, then it's 1, 3, 1, 4, 1, 5, 1, 6. Oops, 1, 6. And I can go 2, 1, 2, 2, 2, 3. Try to make sure that they're in the same line and same columns. And continuing on, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. And I'll be honest with you, when I was in school, I did not want to do this, but it made all the difference in the world. When I did do this, which I started pretty quickly, I wasn't very resistant, but when I started doing it, I was like, all of a sudden I was getting all the answers right. And I wasn't even really having to think about the problem. Where it used to be, I would have to think about the problem. And even though I understood what was going on, I still made mistakes. This eliminated mistakes, and all of a sudden these became problems I got, instead of getting right some of the time, I got right all the time. So what's the probability that the sum equals 1? Sum means we add. Well, if I add 1 and 1, I get 2. So I will never get 1. So this is 0. It's not possible. Probability is 0. What's the probability that it equals 4? Well, in this case, 1 plus 3 is 4, 2 plus 2 is 4, and 3 plus 1 is 4. So I have three possibilities, and there's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 36. So 3 out of 36. I'm going to go back to my calculator just because I want to show you that it will reduce that fraction. But I want to see the original fraction, but 3 divided by 36. And I press the math button and then enter twice, and it comes out to be 1/12. So the calculator will reduce it. What's the probability that it's equal to a 5 or a 6? And again, a sum. Well, if we're looking for a 5 or a 6, we could be looking for 1, 4, 2, 3, 3, 2, and 4, 1, and these. So how many of those are there? Well, when I count them up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and or means add, so that's why we added them all up. And we have, and technically I could do it this way: 1, 2, 3, 4, 4 out of 36 for the 5s, and 1, 2, 3, 4, 5, 5 out of 36, which is 9 out of 36. And if I go to the calculator and I go 9 divided by 36, I'm going to get a math enter, which is 1/4. All right. What's the probability that it's less than 13? Well, what's 6 plus 6? 12. That means all of them are less than 13. So the probability would be 36 out of 36, which is 1. Or you could say it's 100% chance. All right. The next one, a die is rolled and a coin is tossed. Find the probability the die shows an odd number and the coin shows a head. Well, let's make our sample spaces. I could get a 1, 2, 3, 4, 5, or 6. And for the coin, I could get a heads or a tail. All right. Well, the probability, and this says and means multiply. So we're going to have to multiply. Well, the odds, well, that's 3 out of 6. The heads, that's 1 out of 2. And it has the word and means multiply. So this is going to be 3 out of 12. Once again, go to the calculator. 3, I'm going to clear that. 3 divided by 12, math, enter, and I get 1/4. A die is rolled. What is the probability the first 4 occurs on the 7th roll? Well, first off, when we roll a die, what can we get? 1, 2, 3, 4, 5, or 6. And what we're interested in is a 4. Well, the probability of getting a 4 is 1 out of 6. But we're doing this thing 7 times. So that's going to be 1, 2, 3, 4, 5, 6, 7 blanks. And this is the probability of a 4, but this is not a 4, not a 4, and this was just put an N. All of these are not 4s. Well, the probability of a 4 we said was 1/6. So we can put 1/6 right there. But not a 4. What's going to be not a 4? Well, you're going to have to use the complement. So 1 minus 1/6. Well, I can, if I don't know that math, now I could sit there and go 1, 2, 3, 4, 5. So not a 4 is 5 out of 6. And if I wasn't sure of that, I could check it on the calculator because the complement's always 1 minus 1 divided by 6. And math, enter, there's 5, 6. So 5, 6. And this one has to be, and notice I'm using the word and, this one has to be, and this one has to be, and I'm using the word and, which tells me I'm going to have to multiply all of these probabilities. So I'm going 5, 6 times 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 5, 6. Well, how many of those are? 1, 2, 3, 4, 5, 6. So really, we're looking for 5/6 to the 6th times 1/6. So let's see what happens. Here's how I would do this on the calculator. So parentheses 5 divided by 6, close them. And I use the little caret button right here and put the 6, parentheses 1 divided by 6. And math, enter. Didn't like it. So at this point, we're just going to go with a fraction in our answer, I mean a decimal, and it's going to go 0.0558. And for this class, we like to truncate at 4 decimal places. So go 4 decimal places and truncate, which means just cut it off. Don't worry about rounding. All right? All right, the next one. What is the probability I roll 3 6s in a row? All right, I'm going to switch back to a different piece of paper. But what's the probability I roll 3 6s in a row? Well, once again, I can get a 1, 2, 3, 4, 5, 6. Well, probability of getting a 6 is just 1 out of 6. So the probability, because I can only get one of them, there's 1, 2, 3, 4, 5, 6 possibilities. So the probability of a 6 is 1/6. But I'm rolling 3. So that means blank, blank, blank. Well, the probability of a 6, 1/6. Probability of a 6, 1/6. Probability of a 6 is 1/6. So essentially, we could write 1/6 raised to the third power. And I'm going to go ahead and do that. So this equals 1/6 raised to the third power. And that's exactly how I'm going to plug it in the calculator. So parentheses 1 divided by 6, close them. Use a little caret button right here to get the 3. And math, enter. And I get 1 over 216. If you wrote it as a decimal, you'd write 0.0046. Because once again, we truncate. Okay? A card is drawn from random from a deck of cards. Find the probability of getting the 3 of diamonds. Well, a deck of cards, there are 52 cards. Well, how many 3 of diamonds are there? Well, turns out there's only 1. So the probability of getting that would be 1 out of 52. A card is drawn from random from a deck of cards. So let's talk about decks of cards real quickly. In the deck of cards, there are 52 cards. There are 4 suits. And the suits have hearts, suits, hearts, diamonds, clubs, and spades. Those are my suits. And 52 divided by 4 is 13. So in each one of these, there are 13. There are 13 hearts, 13 diamonds, 13 clubs, and 13 spades. And the cards in each suit. So there's 13 in each group. And the reason I'm doing this is I know not everyone plays cards. Is 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice we didn't start at 1. And then the next card, it gets a little weird. It's a jack, then we have a queen, then we have a king, and then we have the ace. And I'll put an A for ace. All right. Well, what they asked for, a card is drawn from random. What's the probability of getting a queen? Well, each suit has 1 queen, but how many suits are there? 4. So there are 4 suits. That means there must be 4 queens. So we have 4 out of 52. Well, let's try see if that reduces. And I know that it does. And I go to math, enter, and it's going to be 1 out of 13. If 37% of high school students said that they exercise regularly, find the probability that 5 randomly selected high school students all say they exercise regularly, none are lying. So first off, we have 37%. So this is 1, and we have probability at 5. So I need 5 blanks because we're doing 5 things. Well, the probability is 37%. Now, it's the probability of the first one, which is 0.37, and the probability of the second, and this one had to do it, and this one has to say yes, and this one has to say they exercise. So essentially, we had to write it 5 times. Now, if I'd been smart, I could have just done this at the very get-go. All right, I usually make, and for me, I usually make 5 blanks and go, oh, 37 5 times, and I can go right there real quickly. So I have 0.37. I highly recommend you use parentheses. It's not always required, but it's very helpful on the calculator and will eliminate errors. Okay, so 0.0069. Oops, 0.0069. Once again, we truncate. Next one, number 11. If 25% of U.S. federal prison inmates are not U.S. citizens, find the probability that 2 selected inmates will not be. Okay, we're doing something twice, so we need 2 blanks. Well, 25% is, and this one can't be either. So really, this is 0.25 raised to the second power. So 0.25, and we get 0.0625. All right, number 12. By the way, I'm going to tell you number 12 was a difficult problem. And I actually always think I have to go slowly through this. A water pump contains 3 components, A, B, and C. The probabilities of failure for each component in any one year is 0.02, 0.04, and 0.07. So there's a 2% chance that A will fail, a 4% chance that B will fail, and a 7% chance of C. If any component fails, the pump will fail. So if A fails, the pump fails. If B fails, the pump fails. If C fails, the pump fails. If any combination of 2 fail, it fails. All right? What is the probability the pump will fail? So they want the probability that the pump will not work. All right? This is a weird problem. Whenever it's a not work, we need to go, okay, what's the probability that it works? So, because we want the probability of not work. So what is the probability? So we want the probability of not work, which means it fails. So I want the probability of work first. We're going to find the probability of work. Well, if the probability of this fails is 0.02, 1 minus that is the probability that it worked. And the probability that this one works is 1 minus 0.04. And the probability this one works is 1 minus 0.07. And so if I do that and I set it up just like that, parenthesis 1 minus 0.02, parenthesis 1 minus 0.09, oops, I want that plus sign, parenthesis 1 minus 0.07. Well, that's the probability the pump works, but I don't want the probability of work, so I need to find the complement of this whole thing. So I'm going to subtract that probability that I just got from 1. So 1 minus this probability tells me the probability the pump will fail. There's about a 17% chance, 17.06, because remember, we're going to 4 decimal places. All right, I'm going to give you just a moment. Let me, you know what? I wrote this wrong. I made an error. This is 1.04. I need to go back and fix this. So let me redo that. Parenthesis 1 minus 0.02, parenthesis 1 minus 0.04, close those parentheses, and 1 minus 0.07, close parentheses. So there's about an 87% chance it'll work, But we want the probability that it fails, so it'll be 1 minus that, which is 0.12506. 0.125056. Now, normally we would truncate and we go 0.1251. All right, 0.1251. All right, I'm going to show you the pretty worksheet answers just so you can see them. So if that helps you out, I'm only going to leave them up here for a moment, but I believe this is about where we cut off at. All right, we're going to move on to, while you're copying it down, I'm going to go ahead and set up to do question 13. And question 13 is back to that pump problem, and it's almost exactly the same as what we just did. Okay, so the water pump contains three components, A, B, and C. The probability of failure for each component in 1 year, 0.02 and 0.04 and 0.07. If any one component fails, the pump will fail. If they fail independently of one another, what's the probability that the pump will not fail? Oh, well, technically, we figured that out already. We wanted to know the probability that it works. Well, all three components have to work for it to work. So this is going to be 1 minus 0.02 times 1 minus 0.04 and 1 minus 0.07. So we really actually already figured that out as part of the previous one. So parenthesis 1 minus 0.02, parenthesis 1 minus 0.04, parenthesis 1 minus 0.07. And we get 0.8749. All right, this concludes this video. Appreciate you watching and look forward to seeing you on the next one. Thank you.